Hi, today we're talking about the unit circle. There's actually two sections in our books about this. I really like the unit circle. I tell my students there's three ways that you could think about trigonometric ratios. You could think about sine, cosine, and tangent as the ratio of sides of right triangles. You could think about them as in what they look like when you graph them on a graphing calculator or on paper and pencil. Or you could think of them in terms of this unit circle. For me, the unit circle is the easiest way to do it. So when I think of like sine of 20 degrees, what's that going to look like? For me, if I picture a unit circle, I could give you a decent approximation for what that's going to be. For me, it makes a lot of sense seeing it as a unit circle. So unit circle, what are they talking about? First thing, when they refer to a unit, well, we're going to be talking about a circle. And for the circle, then, the unit circle has a radius of 1. So consider a circle with a radius of 1, and then they're going to go and they're going to pick a point on the circle. They're going to call that point x and y, or the x and y of there. First thing though, before we get any further, is to say, if you think back to geometry, whenever you do a rotation that's counterclockwise is actually going to be referred to as a positive rotation. If you're referring something clockwise, it's a negative rotation. And we always start over here at the positive x-axis. So this is going to be our 0 point. So positive rotations or positive angles are going to be counterclockwise, negative rotations, negative angles clockwise. Moving on then, so I'm going to start out here with my unit circle, and I threw an x and a y on the unit circle. I want to just first start by labeling different things. And I'm going to start with this point here. This point here, I want to start out by saying that that's going to be 1, 0. That if our circle has a radius of 1, that's over 1, up 0. Then here at the top of my circle, that point is going to be 0, 1, over 0, up 1. The left side then is going to be negative 1, comma 0. And down at the very bottom of my circle, we have 0, negative 1. And those are going to come in handy later. Now we'll actually go and start talking about our angles. Well, we said that we start measuring our angles over here at the positive x. So let me switch to green, and it doesn't show up as well. Switch to purple. So now right here then is going to be 0 degrees. And now if we're going around counterclockwise, we have our positive angles. So 90 degrees then would put us up here at the top of the circle. 180 degrees would be over here on the far left side. And down at the bottom we have 180 plus 90, so 270 degrees. Then to complete our circle, once you get over here to 0 degrees, you could, if you wanted to, also look at that as though it's 360 degrees. So that's going to come in handy soon, but that's how you could label up your unit circle. So maybe pause the video if you don't have that all copied down. And want to jump over into here now. So when we get into a unit circle, kind of what's the point? And want to start by comparing this to what we had before with our right triangles. If I would take this here and kind of run a line straight down, I have a certain x value there on my point. And for that x value, move that over just a little bit, for that x value, that x, what it's really saying is it's going to be this length here in blue. That it's saying how far am I going over to the right. So I could label that then. I could say, well, this here is going to be my x, that side is x. And now my y value, I need to get rid of this. Let me delete that thing there. My y value then is the height. So it's probably more proper to do something like this and say, well, this side of my right triangle is going to be y. And color code that also, so that's going to be my y. And you could put in like a little 90-degree symbol there, showing that I have a 90-degree angle, right triangle. And the radius also, we could say the radius is 1. Now, as I go through this, trying to figure out, well, how could we figure out this x value? What does that x value really equal? Well, if I put in a theta right there, because we always measure angles from the positive x value. Well, now if I'm talking about my x value, let's see. So if we wanted to solve for x, we could look at going back to what we were doing in section 1 and 2. So if you have your SOHCAHTOA, my x value compared to this angle is going to be my adjacent, and we know the hypotenuse. So I could use that right there. I could say my cosine of theta equals the adjacent leg over the hypotenuse. Well, the adjacent leg from this angle is going to be x. Maybe quick flip to blue. So that's going to be my x, divided by my hypotenuse of 1. So you can see then how this x value over 1 equals cosine of theta. So you could then write x equals cosine of theta. In other words, if I know any angle here, if I want to figure out the x value of the point on the unit circle, all I need to do is cosine of this angle, and it tells me how far over to the side I had to go to get that x value. With the y value, we could look at, well, how in the world do you find that y value? Compared to my angle theta, y now is going to be the opposite leg, and we know the hypotenuse, which then brings us over here to sine, that if you have sine of theta, it's going to equal the opposite leg, which is y, divided by the hypotenuse of 1. So then you could say sine or y equals the sine of theta. And that's really important to keep these two things here straight. That if you can keep those straight, it's going to serve you really well in this unit circle stuff. So x equals the cosine of theta, y equals the sine of theta. If you want to find any y value on the unit circle, figure out the angle here with the x-axis, and then punch that into your calculator and you get the y value. Now that'll work for any angle, even if you're over here somewhere. So if I pick maybe 90 degrees would be up at the top, we'll throw on like another 20-ish degrees. So if I wanted to take my graphing calculator, I could say, well, what's that x value? If I punch in, well, if this was 20, so my total angle then is going to be 110 degrees. If I do cosine of 110, it should give me this x value here. If I do sine of 110, it should give me this y value, this point here that's going to be somewhere between 0.9 and 1, maybe 0.92, 0.93, depending on how good I was at estimating my angle. So I want to look briefly at this Pythagorean theorem thing. On the sheet that my students got, it's near the bottom of the page. And I want to say, well, how does that relate to this? Well, maybe I should first write in this y value here. Y we said equaled the sine of theta. The x value equaled the cosine of theta. Kind of put that there on my graph. And now we switch over to Pythagorean theorem. So Pythagorean theorem, if you have a right triangle, it's a squared plus b squared equals c squared. So I'm going to put an a here on my y side, b on my x side, and c over there on my hypotenuse. And I don't know if I'd actually write this on your paper or not, but a squared plus b squared equals c squared. And from there now, let me get this up a little bit more. So if we wanted to look at that then, well, a squared, a is going to be this side here with y. So you could write y squared. I'm actually going to write the trig thing. So we have sine of theta. And we need to square that. We're not squaring theta though, we're actually squaring the length of that side, which is going to be all of sine of theta. So sine of theta in parentheses squared plus b squared. Well, b is this x value over here, which is cosine of theta. So again, we need to put it in parentheses. Cosine of theta is the cosine value that's squared. And that equals c squared. Well, c is 1, so it just equals 1 squared or 1. And that takes us back to one of the properties we had in yesterday's notes. And like I said, this is the one that usually shows up on the ACT in some way, shape, or form. Very last part then gets over to here. So we said, I'll put it in red for dramatic emphasis, that x equaled the cosine of theta. So any x value on the unit circle you could get by typing in your calculator cosine of that angle. Y then is going to equal the sine of theta. You can find any y value on the unit circle by doing sine of the angle. Then you could think back to, if you want to write them in, you could. I'll quick throw them in there. So 0, 90, 180 degrees, 270 degrees. Well now, so if you have this cosine of 0 degrees, so first thing is that we're talking about this point right there on the unit circle. So cosine of 0 is right there. So now if you're doing, or 0 is right there, if you're doing cosine of 0, then you're really finding the x value. So that point right there is 1, 0. So the cosine of 0 degrees has to equal 1. And if you would take a graphing any calculator, type in cosine of 0, it would give you a 1. If you do sine of 0 degrees, now you're looking at the y value of that point. The y value is 0, so sine of 0 has to equal 0. Jump over here to cosine of 90. So now we're talking about this top part of the unit circle. Cosine is the x value. The x value for that point right there is 0. Sine of 90 degrees is the y value of that point right there. The y value is 1. I'd encourage you to quick pause the video a second, go through, fill in the rest, and then start it. I'm going to try to go real fast, so if you actually took my advice, you don't have to sit and listen to me explain them all. Alright, hopefully you did the work. So cosine of 180, we're over here. So the x value there is negative 1. Sine of 180, same spot. The y value is 0. 270 is down here, so cosine is the x value of 0. Sine is the y value of negative 1. Cosine of 450, didn't really prep you for this, but we said all the way around the circle once is 360 degrees. How much do you have to go above 360 in order to get to 450? Well, 450 is 360 plus another 90. So cosine of 450 is referring to that spot there at the top. And the x value of that spot is a 0. Negative 270, we go 3/4 the way around the circle, but negative now we go clockwise. So again, up at the top here we have 90 degrees. That's the same as negative 270 degrees. 3/4 the way around the other way. And sine then is the y value, so that equals 1. So unit circle, great for approximating different values for sine and cosine, being able to do some of that stuff in your head. And we'll look at other things that it's really good for as we move through the chapter. That's it.